come to units and measurements, specifically we're going to do dimensional analysis. Dimension analysis, if we're to define dimension analysis, this is the relationship between the fundamental quantities that are purely natural in nature, that are purely mechanical in nature. So dimension analysis actually it only requires us to use three different quantities. What are those? We have mass, we have time, and also we have length. Okay, so this one, the dimensions for mass are not kgs but capital M. Then the dimensions for this one is capital G. Dimensions for length is capital L. These are the only quantities that normally requires us to solve questions based on dimension analysis.
Okay, so whenever you're trying to write every quantity in a form of dimensions, you have to put it inside the square brackets. That is the only way you are showing that you're writing it using dimensions. Minus putting it inside the square brackets, you are doing nothing. So we need to make sure that you put it inside the square brackets. That is one of the rules we need to follow whenever you're writing the so-called dimension analysis. So for instance, mass, you have to put it inside the square brackets. Same applies to time, you put it inside the square brackets, as well as length, you put it inside the square brackets.
Okay, so how are these three different quantities related? All of them, they can be connected using what we call dimensional equations. So a dimensional equation, this is just an expression that is used to connect fundamental quantities in reference to physical quantities. How can you connect them? Suppose you have area. We know that area has units of meter squared. So meter, this is length, meaning that if you want to write them in form of dimensions, it will be L square. If you have volume is L times L times L. This is going to be equal to L cubed. Suppose we have density. Density is equal to mass over volume. We know the dimensions for mass, that is capital M. This is going to be M over, then that one which is volume, know that it has to be L cubed. So in a best way of writing this in a form of dimensions, this can just be the same as M L to the power -3. So we have a lot of expressions that relates these three quantities. We can also have pressure, which is equal to force over area. By the way, if I'm to find the dimensions for force, I will understand that force is just one and same like mass multiplied by acceleration. What is acceleration? The units for acceleration automatically we are saying has to be meters per second square. So seconds simply means time, meters simply means length, and mass simply means capital M. So if I'm to write the dimensions here, automatically I'll come up with M for mass. For acceleration, it is going to be L, then you say per t square. So writing this in a proper way, you find that this, if it goes on top, you're going to have L t to the power -2, meaning that this is going to be part of the force. So since pressure is equal to force over area, you can divide this entire thing by area, which is having the dimensions of L square. So I understand that this and that can be cancelled. Then you're going to have M t to the power -2. So here we are going to have L. If this same L goes on top, automatically we're going to have M t to the power -2 L to the power -1. Definitely these are dimensions for
Pressure. Okay, so there are cases whereby if they give us an expression to say, show that the given expression like V is equal to V initial plus A T is dimensionally correct. So whenever they say what are the dimensions for each of the quantities involved. Okay, so for instance, yeah, we have the dimensions for each quantity such as velocity, acceleration, and time. So if they say what are the dimensions for volume, I mean for velocity, sorry, they actually mean you have to write them as L t to the power -1. Same applies to acceleration, you write them L as the length, which is meters, then T as the time, which is in seconds. So it will be L T to the power negative 1. All right, so actually what you are going to get from your left hand side has to be equal to what you're going to get on your right hand side. So for you to know that this is correct, this is where now we are using what we call the principle of homogeneity. This principle states that you can only multiply or divide uh, physical quantities of different dimensions, or rather of the same dimensions, but it doesn't apply to addition and subtraction. It even went further into saying it proves to say what is on your left hand side has to be equal to what is on your right hand side. All right, so if someone is to ask to say what are the limitations and also applications for now dimension analysis, we have so many applications, we have so many limitations. So one of the limitations is that it doesn't apply to trigonometric, logarithmic, as well as um, the the exponential functions. It also only works on three different quantities, that is mass, time, as well as the length. So those are the simple examples of the limitations. If they say what are the uh, applications, it is used to check the correctness of the equation. It can also be used to drive uh, quantities from to derive quantities from one point or from one quantity to the other. To derive, not drive, but derive, something like that. So the only thing that helps us relate these so-called dimensional quantities is what we call the dimensional equation. The dimensional equation actually only expresses the fundamental quantities by rating one another or by connecting each other. Yeah, so those are the simple explanation we can give under dimensional analysis. Thank you for watching.